The objective today is to explain how functions with parameters exemplify the concept of abstraction. So this lesson is going to help us when it comes time for us to do that performance task. The second one where we have to create a program and then talk someone through the program and through the abstraction. This is the second performance task after you do the innovation one, where you find out a brand new technology and report on that. This one I think is going to be a bit harder, so we're going to need to spend some extra time on it. So right here I'm saying go ahead and buckle up for today's lesson because it's going to be super heavy on the language, on the vocabulary, but I'll try to constantly go back to the whole idea that all we're doing is explaining our program that we create. So let's start with a quick review, the idea of documentation. The primary documentation for Linux commands and utilities is the man page system. So if you're using a Linux operating system, all you have to do when you don't know what something does is man page it. There's also GNU, and now GNU stands for GNU's not Linux, or Unix I think that's like a recursive acronym where inside of the acronym of GNU stands GNU's not Unix. So I've never seen an acronym like that before, but it's a great way to memorize this one at least. And so for GNU, primary documentation is the info documentation system. So try info, and this is also available in Emacs, which is my particular favorite text editor. But moving forward, just remember that newer open source projects have been leaning towards wikis. So just like Wikipedia, I know Star Wars, that whole Star Wars universe has a great wiki page and a great website that is kept up by the fans, and it is probably one of the best examples of documentation for a fan world like that. Okay, before going any further, let's remember that a parameter is an extra piece of information that you pass to a function to customize it for a specific need. So if you are really enjoying this and want to see other languages and how parameters work in other languages, you can check out something called EduBlocks. It's essentially Python version of Blocky. Remember, I do not like the Blocky programming so much, but if it helps you learn, then definitely go for it and use it. So a comment block doesn't do anything when you run the code. It is a simple way to leave notes in code. So when we are creating this performance task, you can leave yourself notes through comments, and then that should help you explain your code. Now for programmers, they write in their code comments for two main reasons. Just sharing code with other programmers would be the first, and the second is remembering their own thoughts or plans for the code when they had written it. So your Think Right Share here is in this context. Which reason do you think is the most important to do comments inside of code, and why? Here I'm saying for both cases, programmers write comments into their code to explain their thinking to a human reader, not for the computer, right? Writing your own comments is a skill you'll develop over time, and at this point you might want to write a ton of comments just to help yourself process your thinking. So here's a fun little exercise I found. It says the programmer circle. You design the document, and then you code, and then you compile, and then you run, and if it's successful, the customer will likely report an error, and then you ask yourself what happened, so you'd Google that, and then you'd end up finding something that you copy and paste, and then what that will force you to do is rename your variables, which will include you needing to add comments, and then if you add comments you're likely to add more code, and then the process starts all over again. This reminds me of that storybook, If You Give a Mouse a Cookie. Okay, and then he'll ask for milk, and then he'll ask for a nap, and all these things. So this idea of needing comments during the development cycle, I feel like it's just something you're going to have to get used to. So my Think Right Share on this page is how do you get to the add the comments branch of this algorithm? And if you don't know what I mean by this, go ahead and ask me in class. Maybe I can do a better job by pointing. Okay, I'm pointing actually to this add comments part. And the question is, how did I get to the add comments part? Don't overthink it. It's really easy. There's another command that lets you set the pen color called pen RGB, and then you put the RGB value here. And then there's a fourth one. What does A stand for? It says here the first three parameters are for values in the range of 0 to 255 for the red, green, and blue channels. The fourth parameter, A, stands for alpha. The alpha channel for color lets you set the level of opacity as a decimal value between 0 and 1. It is interpreted as a percentage, so 0.5 equates to 50% opaque. For example, pin RGB, so here's some numbers, it's going to be 50% see-through, basically. That's what opaqueness is. And when you're doing the code.org lessons, it is part 8 under lesson 7. Writing functions with parameters is a simple idea, but it traditionally has some devilish details for new learners of programming. The basic idea here is that you often want to write a function that takes some input and performs some action based on that input. For example, the turtle function move forward is much more useful when you can specify how much to move forward, as in 100 pixels. So rather than just a fixed amount every time. Your think, write, share here is what is the basic idea of functions, according to this paragraph. It's very common to encounter situations where, as a programmer, you realize that you basically need to duplicate some of your code, but you just want to change some numbers. That's a good time to write a function with a parameter. The parameter just acts as a placeholder for some value that you plug in at the time of the function call. So think, write, share, what did I just say the parameter does in a function? I feel like when you write these things out, you're much more likely to remember them, okay? So that's why there's so many think, write, shares today, because like I said, it's heavy on the vocabulary, and I want you to be able to write out your thoughts in terms of code. That way you could do it on the performance task. It says here, just like it's considered good practice to give descriptive names to your functions, the same is true for the names of the parameters themselves. So for example, draw square, now this is the side length. It's better to say it like this than draw square and then like stuff, or draw square side. Being detailed in your code is very helpful, not only to yourself, but to anybody who may need to read your code. Think, write, share here, what would be a good parameter name for draw circle? So I hope your brain's not hurting too much by now. If your nose isn't bleeding yet, what we're going to do is take the beginning part of this lesson, the things I just explained to you, and we're going to put them in the format that the College Board is looking for. So here it says that the AP Create Performance Tasks asks you to write about an abstraction that you developed and wrote into your code. Most of the time that means identifying a function or a procedure you wrote to help manage complexity in your program. Here's the actual prompt from the Create Performance Tasks, so you'll be reading this when you go to take the test. It says capture and paste a program code segment that contains an abstraction you developed individually on your own, marked with a rectangle. So you use the rectangle to prove that you have been developing that particular piece of abstraction that you're talking about. This abstraction must integrate mathematical and logical concepts. Okay, that's easy, don't worry about those big words. And then explain how your abstraction helped manage the complexity of your program. And all of this needs to be done in 200 words or less. So here's a good example, lots of code, here's the rectangle. Imagine that you wrote this and are composing an AP response about how this abstraction manages complexity. Ignore the requirement that the abstraction must integrate mathematical and logical concepts, okay? Just ignore that for this practice response. Just write about managing complexity. If you want a better way to see this, you could go to the link here. So basically it says function draw fish, and you got the size, red, green, and blue. And then the pin RGB color would be here, the pin width here, pin down there. All right, and then it just keeps going, okay? So let me go to this next slide where I give you an exemplary explanation. All right, there are several ways a student could talk about managing complexity using this example. First of all, you have code reuse. Describe how the parameterized function compartmentalizes or encapsulates the drawing of a single fish in a way that lets the code be reused to draw many fish. And then the second part here, you can write or talk about the use of parameters. This describes how the parameters allow you to call the function with a single random number as a value and then reuse that value several times throughout the function code. There's no way with a parameter variable, for example, to pick a single random number you want to use as size and then use that number in multiple places. So using the two ideas of code reuse and parameters, I want you to go ahead and attempt to put this answer in your own words, okay? If you need a sentence starter, here you go. It says, explain how the abstraction helped manage the complexity of your program. So you look here, and this is just what I read to you, and your sentence starter would say something like, this abstraction helps manage complexity by, then make sure you get the word code reuse and parameters in there, and you should be good. Though I don't want you to use this, I'll go ahead and leave it right here for you to read. An answer like this would get you an A. And now for the DOL, that was the lesson. So abstraction is often used to indicate cases where we focus on a general case and ignore a specific instance of a problem. So given this meaning of the word, how are functions with parameters an example of abstraction? Lots of writing today, but I look forward to reading your responses.